Hey everybody, this is Drew here for the last video in our series, The Evolution of a Video Game. We had planned to make 4 videos, but we ended up spending more time in development than we initially planned. In this video, I'd like to let some of the other members introduce themselves and talk about their roles in the project.
Hey, my name is Brett. At the beginning of the semester, I had the most experience in video game development on our team. Because of that, Skinner decided to make me the team lead. I want to say that the main function of the team lead was to motivate, but the team never needed it. I worked on several different aspects of the code, including an original architectural design, animations, state management, HUD and menus, and boss scripting. In our game, each actor has at least one animation player. Each animation player is responsible for drawing the state of the actor. A minion, for example, has one animation player and is fairly straightforward. A boss, on the other hand, is drawn in layers and has multiple animation players. In the previous video, animations were working pretty well. However, problems occurred with dynamic animations. Our animation player needed to be able to play animations forwards or backwards. It also needed to have functionality to loop or play once. To fix these problems, the animation player was given a queue of animations as opposed to just one. This allowed us to enqueue animations as input was received from AI or controllers. To make coding different states of the game easier, the team needed some state management. The best way to visualize this is as a finite state machine. The game starts in a menu state and goes to another state based on the input. The game has a current state variable which has an update and draw method. The update method returns a game state, and the draw method is a void function. Some examples of states in our game are the menu state, character choose state, playing state, and a splash state. We tried to use inheritance in our game states, especially in menu and splash states. The menu state consists of several options which can be selected from. The menu state is inherited by the main menu, stage selection menu, pause menu, and disconnect menu. This allows us to centralize logic in the menu state class, which makes subclasses extremely simple. A preliminary version of the HUD was in the last video, but a lot of work has been done on it since. After players choose their characters and are in a game, another player can connect a controller to select a character in-game. After the selection, players see their character and a health box. There is also a communal display of information on the far left. It shows progress through the current level, total amount of points, and lives remaining. The main feedback in the user study for the HUD was that people did not look at it often, if at all. This is understandable because the game is extremely chaotic. To make looking at the HUD easier, we made the HUD boxes color-coded based on their character. Boss scripting was an extremely fun and challenging portion of the game development cycle. It was important to the game because players will have unique and memorable experiences with the bosses. Most of the creative ideas came from our artist, Justin. The programmers then bounced around some ideas for the bosses and jumped in. The first boss scripted was the giant snail. His attack mechanisms are a turret, missile launch, and a cannon. Each second he does at least one attack. The difficult part of this boss was positioning particle emitters and making animations play correctly. The next boss scripted was the chopper. The main difference between this boss and the previous one was that the chopper moved. This ended up being a little simpler than we first imagined. This boss also needed to drop enemies to help. The chopper was the first time that multiple animation players were put onto one actor. We have one for the blades of the chopper and one for the base of the device that opens and closes. The third boss scripted was the dragon tank. It also moved from side to side and had some rotations to deal with. Animations were straightforward on this boss, and it did not take too long to code. By the time we needed to script Alexander, the last boss, we had enough knowledge to do it in less than a couple of hours. Of the 4 bosses, the giant snail was the most tiresome to code. That is probably because we had no boss fight experience when he was coded. The bosses became easier to code as more were finished.
My name is Justin, and I was in charge of the art for The Fall of Evil. We wanted the game to be funny as well as fun to play. For this reason, I asked myself this question when I came up with a design for a weapon, enemy, or boss. Is this completely ridiculous and absurd? If the answer was yes, it went into the game. For the art style, I wanted something that could be dark and violent, yet cartoony and humorous. For this reason, I decided to mimic the art style of Jonan Vasquez, whose work is known for being funny, yet dark and violent. My background in computer science came in handy when designing sprite sheets. It helped me know how best to arrange the sprite sheets to make it easy on Brett, who is writing the animation player. Sprite sheets are divided into cells that were each the size of the entire sprite. Each row contained the different frames of a single animation. The animation player goes to the appropriate row for an animation and then iterates through the frames. Bosses were handled slightly differently than the enemies and players. Bosses were drawn in individual layers so that multiple animated parts could play simultaneously. Each row of the sprite sheet contains a different layer and any animations that layer may have. Having the layers being drawn separately and on top of each other allowed the bosses to use multiple attacks at once and created the illusion of depth for some bosses, such as the snail retreating into his shell.
Hello, my name is John Lakey, and I was in charge of the level and artificial intelligence design in the game The Fall of Evil by Revision 119. So as I said, I was in charge of level design, and basically the game is divided up into 4 large parts, called stages. We further divided these stages into 4 levels each. So there are 16 levels throughout the entire game. The different types of levels are base defense, search and destroy, escape from danger, and boss fights that all have various objectives. We designed our levels using a tile system where the levels divided up into discretized sections that you put props into, and all these props have different functions. Like when you're traversing the level, you can come across barricades or towers or trucks, and really they're just two-dimensional sprites on the screen that all do different things when the player comes across them. This allowed us to implement anything that we wanted inside the level, and we just draw something up, write a function for its interaction, and put it in. It was very dynamic. It allowed us to do a lot of things. So as I said, I was also in charge of designing the enemies, and I'm not sure if the AI is actually deserving of being called artificial intelligence, because really they're just finite state machines that do different things depending on where they are in relation to the player. We implemented, as I'm sure Drew has talked about before, we implemented an actor class that each enemy derives, and I redefined functions for their attacks and their players for each enemy to give them all a unique attack, and they all behave in a unique way to bring a lot of variety to the game. There are only 4 enemies at this time, but we can create as many as we want, and it wouldn't take very long because of the way we've implemented our enemy class. We feel like we've created 4 very different enemies that behave in very different ways to create a very unique experience when you're playing. So one thing to note is that both the level system and the enemy system underwent dramatic changes during the development process. The level system went under a very dramatic change when we decided that levels should have one set of props and one set of enemies, and it should be very different for each stage. This was completely different than what we had originally set out to do, but the way we had set up our level classes and the way we had inherited our data made it very easy to change, but the change was quite drastic and changed the gameplay a lot.
Well, that about wraps it up for this series. I'd like to quickly thank the team for all the hard work, great attitudes, and all-nighters they spent with me getting this game ready for prime time. I had a lot of fun making the game, and I think it was effort well spent. We hope you've enjoyed listening to us talk about our own game, and we hope you'll download it and tell us what you think. We'll have it hosted on our website where you'll be able to find out more information about the game that we didn't talk about here, as well as read our character bios and inspirations. Feel free to leave comments if you have any questions or feedback. Thanks!